Okay, so this problem says that a student is pushing their physics homework in a wheelbarrow that totals 55 kilograms. He pushes with a force of 210 newtons, and the coefficient of friction is 0.135. All right, so like I tell all my students all the time, the first thing you're going to do is you're going to strip this problem of all of its parts, and you're going to write all of that information down. So the pertinent information that you need to know right now is that mass is at 55 kilograms, the force applied on the block is 210 newtons, and the mu of the two surfaces, right, that relationship value of the two surfaces is 0.135. The other thing you can also write down all the time is the value of little g, because this is occurring on Earth. So you could write down 9.81. You could also put a negative there. You don't have to write 9.81 with a negative, but it's a good practice to treat it with a negative. That just indicates that the motion or the acceleration or the force is acting in the downward direction. So that's all the negative means in this problem. Positive would mean that it's acting up. Or if you're dealing with left to right, it would be left would be negative and right would be positive. It all depends on the convention that you set. But for most people, it's up is positive, down is negative, right is positive, left is negative. And then the problem is asking us to draw a free body diagram. So you're going to go ahead and do that. Draw the ground and draw the object. Okay, there's the free body diagram showing that the force applied is 210 newtons. I chose to push it to the right because I always do, but you could push it left as well. Remember that friction always opposes motion. So if the object is moving to the right, which it's not very clear whether or not it is already moving, but I guess we can assume that it's because the student is pushing. I guess because I don't know, they're only giving you one coefficient of friction, so it's possible that this box may not move, and it's possible that this box is moving. So we're just going to do the math and figure out what happens, and we're going to have to make a determination what's going on there. Okay, so how I would attack this problem first, after I got all of my information written down, I got my free body diagram drawn, is I would calculate the force of gravity. Ooh, I moved our earth line there. There we go. So I'm just move this out of the way. I'm going to do the work on the blue side over here. Okay, so the force of gravity is equal to the mass of this thing times little g, right? And we're on Earth. The mass is 55, and little g is 9.81. And that works out that the force of gravity is equal to 540 newtons. And that's going to be a negative value because, like we said earlier, it's going down. So and that's my force gravity, Fg, just like that, right? So just as a reminder, your free body diagram is there just to keep you organized and understand the system. And keeping it organized and neat is really smart because it allows you to keep clear focus on this problem. I know that myself, I have ADHD, so it's really important that I do shit like this where I box the problem up and I say, okay, that's my FG, that's what I'm working on in that section of my paper. And then I will draw myself another box around the next calculations, and I'll make sure that I keep it nice and notated. This way I don't lose where I'm at, right? Also, if you solve these problems the same way every time, you develop a sense of how the steps should go in order, and you keep a clearer mind as from step A to step B, because there's a lot of steps and there's a lot of things to consider, but this really is actually pretty simple. All right. So force of gravity here is 540 newtons, and now I want to find the force of friction is equal to the force normal usually times the mu, but in this case, we can just use force gravity, no problem. So force of friction is equal to 540 times the given mu, which is 0.135. And what I like to do here is I like to look at this mu is representing, if you just move the decimal over two places, it represents 13.5%, right? So what you're essentially doing here is you're just saying, okay, the friction value is 13.5% of this number here, right? So I'm just going to make a quick determination. Do I believe that 13.5% of 540 is larger than 210? If it is, then the block will not move. If it isn't, then the block will move and it will accelerate. Turns out it's only 73 newtons. And this is going to be acting in the negative direction because we're moving it to the left. And again, I'm going to box this out just to keep myself super organized, right? So my force of friction is no longer an unknown value. I now know that it is 73, right? So now this is a fight. This is a fight between my 210 and my 73, okay? I guess what we're going to do is we're going to just openly admit that this is a garbage problem because the coefficient of friction changes once the object is moving, right? So this is kind of a weird wording. I get where the teacher's trying to go with this, but the student is pushing their physics homework. I guess you could assume that that means that they're moving it at a constant velocity, that they're applying this force and they're pushing it and it's already in motion. You could assume that that's true. I would be more careful with my wording on this because we're teaching friction here and I want to make sure that my coefficient of friction lessons are learned, that there is a static coefficient of friction when objects are at rest, and there's a kinetic coefficient of friction when objects are in motion. But we're going to proceed like the object is already in motion. So this is a fight between this 210 and this 73. What I like to tell my students to do is not erase them, but just cross off 73 and then cross off the 210. Make sure you subtract 73 from the 210. That gives me 137. And remember, that friction force is not going away. What we're doing is we're just understanding that 73 of it is canceled out. 73 of the friction force is canceling out 73 of the force applied, right? Because these forces are equal they're opposite in direction, but they're not the same size. So they're fighting each other, right? Exactly left and exactly right. They're fighting each other. So we're going to find the difference. So it's 137 overall pushing to the right, okay? So now, after that, we're going to go with Newton's second law that says that force is equal to mass times acceleration, right? So the force applied here is 137, and that's equal to the mass of 55 times the acceleration. In order to solve that problem, you're going to use basic algebra, and you're going to divide by 55 on both sides to move the 55 to the other side. We're doing the opposite operation. And so this is going to be 137 divided by 55. So it's going to be like roughly 2.2 or something. I was wrong, 2.5. So my acceleration is equal to positive 2.5 meters per second squared to the right. So the object is going to gain 2.5 meters per second every second that it's moving. So if this person pushes it for 10 seconds, it will be traveling at 25 meters a second after those 10 seconds because it's going to gain 2.5 meters per second every second that it's being pushed in this situation. If the student chooses to push less, the object will accelerate less. If he chooses to push more, the object will accelerate more. All right, hope this was helpful.